Hello students, today we will study thermodynamics chapter. This chapter will be in parts. Okay. Then first, what is thermodynamics? Thermodynamics so thermodynamics is the branch of physics that deals with the concept of heat and temperature and interconversion of heat and other forms of energy. Means what? Thermodynamics deals with interconversion. Interconversion means heat exchange between two systems or system and surrounding and other forms of energy. What is other forms of energy? Other forms means heat is transferred into the work done. We will see throughout the chapter what is work done, what is heat interconversion, and main we need to know what is the difference between heat and temperature. So what is heat and temperature? So in this diagram we can see there is a burner. So this burner gives heat to this beaker, in which beaker there is water. In this beaker there is water. So I will name all this. This is heat. This is water. And due to this there is rise in temperature. What is? There is rise in temperature of water. There is rise in temperature of water. Okay, so heat is the form we give to the system and temperature is the form which is raised due to the heat. So hope you understand the distinction between heat and temperature. We will now move on to our next point, which is thermal equilibrium. So now what is thermal equilibrium? Thermal equilibrium is the condition when there is no heat transfer between two systems or system and surrounding. So I will draw a short diagram. Suppose here are the two systems, system A and system B. System A has temperature 100 degrees Celsius and B has temperature suppose 0 degree Celsius. This is first condition or before equilibrium. And after equilibrium what will happen? So I will again draw the same system. A and B. Now here we can say that the A and B are in contact with each other. So there is heat transfer between A and B. So now the heat donor is A system. Why? Because A has highest temperature and B has lowest temperature. So A will give heat to the B, and after some time they both will have same temperature, which is 50 degree Celsius. When they both will attain the 50 degree Celsius temperature, after that there is no heat exchange between A and B. Neither A will give to the B, neither B will give to the A. So this is the after condition. After condition. Okay. Now in this thermal equilibrium, we have to study what is adiabatic wall and what is dithermic wall. So now see what is adiabatic wall. We will take the same system. So now see, if A and B are the two systems which are separated by adiabatic wall. I will draw adiabatic wall by another color. This is adiabatic wall, and A and B, both the systems are insulated by outer surrounding by dithermic wall. So I will color them also as blue. Okay. Now we can see that A and B are separated by adiabatic wall, and system and the surrounding is separated by the wall blue, which is dithermic wall. This is dithermic, and this is adiabatic. Now we will see what adiabatic wall does. Adiabatic wall does not allow heat exchange between A and B, means A cannot transfer heat to the B, or B cannot transfer heat to the A. This is adiabatic wall. The heat exchange between A and B is not allowed in adiabatic wall. But what is dithermic wall? Dithermic wall allows exchange of heat between system and surrounding, or system to system. Means here blue color is the dithermic wall, means A can give heat to the surrounding, outer surrounding, and B also can give or take heat from the surrounding. Similarly, after some time, A will give heat to the surrounding and B will get that heat from the surrounding. So both the systems will be in equilibrium after some time, even though they are separated by adiabatic wall. Now in dithermic wall, we will have another diagram similar, but the wall between A and B will be dithermic. So now in this diagram, we can see that the system and surrounding are separated by adiabatic wall, means this is adiabatic, and the blue one is dithermal. At here, at this stage, the system will transfer heat from A to B. What dithermal does is that dithermal allows transfer of heat from A to B or B to A. So if A has the higher temperature, B has a lower temperature, after some time A will give heat to the B, so they will be in thermal equilibrium. So this is dithermic wall. I will write down the short note about what is adiabatic wall. It allows exchange of energy. So hope you understand what is thermal equilibrium, adiabatic wall, dithermal wall, system and surroundings, heat exchange. Okay, then we will move to our next point.